Today we will do 3D electric field due to point charges, but triangle. Okay. So let us say we have a equilateral triangle, 3 vertices A, B, and C. Each vertex has a point charge Q at its location. So 3 identical charges are placed at the vertices of an equilateral triangle. Okay.
Yes.
Equilateral triangle of side A. So each side is basically A. Now, let D be the center of this equilateral triangle. And where do we have to find the electric field? We have to find
On D.
at a distance. D also we will find, and also at a distance x above, at a distance x above the. So let us say there is a point E at a distance x above the center of the equilateral triangle and perpendicular to the triangle, perpendicular to the plane of triangle. That means our line ED is perpendicular to the plane of ABC of the triangle, or you can say the plane containing ABC. Clear? Now again, just like yesterday, we will look at it from a top view. So if I will draw the diagram for top view, we have this equilateral triangle of side A, equilateral triangle. So we will be able to see A, B, and C are the vertices, and D is the center of this equilateral triangle. And where is E? E is basically perpendicular to the plane of the board at this point.
It will form a pyramid still now.
But the actual practical pyramid has a base of rectangle or a square. Actually, it has square. This will also become a pyramid with the base of a triangle. This is basically like that, you can say diamond or something.
Yeah.
Right? A diamond which has a base of a triangle and comes it. So where is my vertex? Where is my point E? Point E is over here. Clear?
Yes.
Now, after this, so we need to find two things. A part, find the electric field at point D, which is the center of the equilateral triangle, and also find the electric field B part, which is at a point E, due to all these 3 point charges. Okay. Usually if we say find the electric field at D and D, that's enough. It is obvious that we are finding electric field due to all the 3 point charges. Clear?
Yes.
Next. So let us start off with A part. Now in A part, the electric field due to B will be away from B. The electric field due to A will be away from A. The electric field due to C will be away from C.
Away from C. Yes.
Okay. Now, all the 3 charges are identical, Q, Q, and Q. Also, the distance between the center and the vertex is also equal. Correct?
Yes.
If I say each one is electric field E, E, and E, we have 3 vectors. Can I say at equal angles to each other?
Yeah.
3 vectors making an equal angles. 3 vectors making equal angles with each other, having equal magnitude.
60 degree.
60 degree. What is the angle between one electric field and the other electric field? 120 degree. See, I will show you over here. Electric field due to A is downward. Now, electric field due to B is 120 degree anti-clockwise to the first vector.
How can you tell that it's 120 degree?
I am showing it. In some time you will know. Electric field due to A is downward.
Yeah.
120
Yeah, 120.
Because you have to cover 360 degree.
360 degree. Yeah.
If you remember, I told you in polygon law of vectors, I told you we are going to use it in electrostatics only. In polygon law of vectors, if regular polygon, we did irregular polygon n sides, right? Regular polygon means what? Each side has equal magnitude. Here we have three vectors having equal magnitude, making an angle 120 degree with each other, such that when I start with the first vector and come back to the first vector, I have rotated 360 degree. Do you remember that?
Yeah, so
therefore, according to polygon law of vectors, okay, you can solve it otherwise also. You can take the components and also prove that the answer will come, which I will show. But I am also introducing a little bit of polygon law of vectors over here, taki you get habituated to that also. So according to polygon law of vectors, we are saying, according to polygon law, we are saying, because this is a three-sided regular polygon, those three vectors will make three-sided regular polygon, right?
Yeah.
Therefore, the summation of all the electric fields acting at summation of all the electric fields acting at point D will be 0. Okay? ठीक है?
Yeah.
है ना?
Yeah, acting 0. So theta will be 2 pi by L.
And I told you that the total angle that we will traverse is going to be 360 degree.
Yeah.
Now
Your
let me...
length will be same.
Correct. Magnitude should be the same. Now let me prove it to you. Okay. I am going to draw those three vectors over here. Okay. So one vector is E downward, other vector is at 120 degree to the original vector, another vector is at 120 degree. All three vectors have equal magnitude.
Yes.
Correct? Now understand. How do I understand the polygon law application over here? I am given these three vectors. How I came to these three vectors is using my electrostatic figure. No problem. इलेक्ट्रोस्टैटिक्स के हिसाब से कुछ तो करके मैं यहां तक पहुंच गया. अब भाई ये पॉलीगन लॉ ऑफ वेक्टर से मैच करेगा, ये कैसे बताता हूं? डू यू रिमेंबर द स्टेटमेंट दैट आई सेड, for resultant of vectors I need to place the tail of the second vector at the head of the first vector.
Yeah.
That statement. Another statement that I told you is that I can shift the vector anywhere in the 3D space without changing its magnitude and direction, and the vector remains the same. Correct? So now focus over here. Okay? How am I going to prove that this situation suits polygon law of vector? When a faculty is explaining, everything looks like obvious. Yeah, everything is fine. But I have to be specific about what is what, because later on I'll get confused when I look at it by myself. So how do I prove that this suits my polygon law of vectors? Is that I am going to shift this bottom vector over here. That means I'll place the tail of this bottom vector over here and the head eventually comes over here. Clear? Something like this.
Yeah.
Okay. Now I'm going to bring the third vector and place it over here. Are you getting my point? Okay.
Can you repeat it?
So let me say 1, 2, 3. I will shift the tail of my first vector to the head of my second vector. And I will shift my tail of third vector to the head of my first vector. This becomes 1 and this becomes 3. Now my equilateral triangle forms like this, wherein this is my first vector, the second vector is this vector, and my third vector. This is how, by rearranging the tails and heads of my vectors, and I also told you in polygon law of vectors one statement, the next vector's tail should be at the head of the previous vector's head. The next vector's tail should be placed at the previous vector's head. And every vector should have the same thing. Third vector's tail should be at the second vector's head. Fourth vector's tail should be third vector's head. When I arrange all in this way, and if my vectors completely cover 360-degree, and also I told you my last vector should be at the head of the first vector. This becomes a closed polygon, right?
Yes.
It can also be an irregular polygon till it is 0. In our case, it becomes an equilateral triangle, a regular polygon, still it is 0. Either which way, from this figure to this figure, I am showing you how my polygon law of vector I am going to apply. So when I have this figure, redraw it this way. Once it becomes a regular polygon, you know that the summation of all the vectors is 0. Here?
Yes.
Now let me prove it to you in a analytical sense, solving. So let me extend this vertical line. You know each vector angle between any two vectors is basically 120-degree, 120-degree, correct? Up also it is 120-degree. But this fellow's extended line will be an angular bisector because of symmetry, therefore it is 60-degree, 60-degree.
Yes.
Correct? So I have two vectors E and E making 60-degree with the vertical line. Already you have solved a lot of questions like this. Can I say that will be 2E cos 60? Component of E will be E cos 60. Component of E will be E cos 60. Therefore, my figure will eventually come out to be upwards I have 2E cos 60-degree and downwards I have E. Correct? Also, the sin 60 due to those two vectors will cancel. E sin 60 towards right side, E sin 60 towards left side.
Yeah.
So these two components will cancel due to the top two vectors, and 2E cos theta cos 60 will be upwards, and due to the bottom vector I have E in the downward direction. Correct?
Yes.
But what is 2E cos 60? 2E into cos 60 is half. Cos 60 is sin 30, which is half. So 2 cancel, 2E cos 60 is nothing but E. So I have E downward, E upwards, that also cancels. Analytically also I can prove that my resultant is 0. Is this clear? In square it was easy because diagonals were cancelling. It was easy to understand. Today in square,
In that
diagonals were cancelling because you have 4 vectors. If you have 6 vectors also, it is easy. They will cancel each other opposite. When you have odd numbers, you will come to this kind of a situation. Take component. If you want to prove it analytically, if you want to prove it geometrically, from here to here I have created it a polygon, and according to polygon law of vectors I know net electric. Is this clear? So when I have odd number of vectors, it is easy to use polygon law of vectors. Understood? कहाँ पे? बोलो.
that diagram.
This diagram,
Yes. No, the above one.
the above one.
Yeah, the one where you're forming 60-degree.
We took components.
Yeah.
Component due to this E vector along vertical line will be E cos 60.
Yeah.
Component due to this fellow will be E cos 60. So
And that side.
upwards I have 2E cos 60. Bottom I have E. Apart from this, another component E sin 60 towards right.
Why bottom only E? It should be E cos theta, no?
Bottom E is already there here. We have 3 E's in triangle.
I know.
So the third E is already downwards. The 2E cos 60 I am getting is because of the other 2 E's that I have.
Yeah.
ओके ई है उनका दोनों का 2E cos 60 ऊपर है. तीसरा ई तो वैसे ही नीचे है, तो ये तीसरा ई जो
So
नीचे
how will you strike off?
with what? Strike off what?
Previously in square you did the reaction and action thing, right?
In square we did not do reaction action. We did reaction action in string, gravitation.
So it was getting cancelled.
In square what happens is our diagonals will only cancel each other.
Yeah.
Due to this fellow, it is in this direction, and this fellow, it is in this. Both are opposite, equal in magnitude. Easily it will cancel.
Yes.
When I have even number of charges, they will cancel each other automatically. It is easy to understand. But when you have odd number of vectors, in this case, I need to take component.
Yeah, okay, you took component, but how will they cancel each other?
Which E sin theta cancelled. This is fine. E sin 60 cancelled E sin 60. Okay.
Yes.
But here I have what? 2E cos 60. Here 2E cos 60 is half value. 2 and half got cancelled here. Only E is remaining. So due to these two vectors, in the upward direction I have E. Whereas originally I already have E in the downward direction. Now this fellow will cancel 2E cos 60. These cancelled this fellow and this fellow cancelled. Bottom cancelled top.
So you have
Horizontal
only one E cos theta left.
2E cos theta itself is E.
Yeah, but it's 2 times, right?
2 times of E cos theta is E. 2 times of E cos 60 is half. 2 times of that only is E. Two times of, let us understand it here again.
Yeah. I got it. Yes.
E and E. So we will come across these things again and again multiple times. So I have two vectors. Magnitude is E and E. So this you have done multiple times. Upwards you will get 2E cos theta. यहाँ पे थीटा लिखा है मैंने, ठीक है. और हॉरिजॉन्टल डायरेक्शन में E sin theta आएगा. करेक्ट?
Yes, correct.
तो
And
ये
bottom में E.
these are the components due to 2 E's.
Yes.
ऊपर के तरफ 2E cos theta because E cos theta added each other, and sideways E sin theta. For
Yes.
any angle theta, side fellows will cancel. We have done this electric field due to 2-point charges. So 2-point charges, we had E and E. We have solved force also. We have solved many problems. F and F sin theta always cancels irrespective of theta. Now, in our case, this theta fellow is 60 degree. In this.
Okay, so cos 60 is half, so 2 into 4.
So therefore, this entire fellow will be E.
Yes.
Now this E is cancelling the bottom E. Everyone cancelled everyone. Only because theta is 60 degree.
So it's not, you can't tell that in every odd n sides you
For
can't
even number, everyone will have their own opponent, so they will cancel each other directly.
But in odd you can't always cancel.
For odd, I will face directly, they will not cancel. I will have to eventually take components and eventually it will cancel.
What if they didn't give you 60 degrees? So it wouldn't have been cancelled, right?
If it is not 60 degree, then it is not a regular polygon. Suppose theta is 30 degree. Why did I get 60 degree? Because it was 120 degree.
Yes.
Each had 120 degree. That's why 60 degree came. Why was it 120 degree? 360 degree divided by 3 is 120 degree. Because 360 divided by 3 is 120, this fellow regular polygon, it came as an n-sided, 3-sided regular polygon. Suppose it is coming 30 degree. तो वो regular polygon बनेगा ही नहीं.
Yeah, it be n-sided polygon.
30 degree, ये 30 degree, ये 30 degree, वो n-sided बनेगा ही नहीं, क्योंकि total 60 degree हो गया, मतलब बाकी का बचा हुआ 300 degree है. Are you getting my point? So each will have here, अगर मैंने यहाँ पे E downward draw किया, तो ये 150 degree, ये 150 degree में divide होगा, correct? Now what problem do you have? This is 150, this is 150, this is 60. How can it be an n-sided regular polygon if angles are not equal?
Yeah.
All the angles should be equal for an n-sided regular polygon.
Okay.
Is this clear?
Yes.
So this is also a reason why I am saying, not that I am complaining, I am saying yesterday's also do it twice without seeing today, and today's also do it twice without seeing. So before without seeing, you will have to see it 2-3 times and do. Then only you will have a good hold on it. So total what will happen is yesterday's square thing you will do 2 times without seeing. Today's probably you will do some 2-3 times with seeing, then you will have a proper understanding, then 2 times without seeing. So total 5 plus 2, total 7 times, 8 times hoga. But what will happen in this journey is you will get even more closer to the vectors story. Again, we are doing n-sided polygon vectors only. Kaha electrostatics hai? Once I said this is electric field, this is electric field, this is electric field. Now I am in vectors, solving vector problem. Understood? Okay, take this down right now. Okay, so we have only done A bit. Take this down right now. After you're done, I will erase it and then we will do the B bit. Okay, and if you have any doubt, ask me. Hi guys, I hope you enjoyed the session. If you think this video was useful, don't forget to like, share and subscribe to my channel. Also, I'll be waiting for your comments in the comment section. See you in the next video.